here's how to do 10, 11, and 12. The first thing you need to do is go to your graph and make sure you got your value for m. So mine is 6.2. Use your value. Don't use mine. Okay? So go to your paper then, and you're going to write that value in for the slope. So mine was 6.2. Then you're going to set that equals to 4 pi squared over g. We're going to try to get g by itself, so that means multiplying g to both sides. Cancels over here. Now to get g by itself, we divide both sides by 6.2. Again, you're using your own number. So what you end up with is this. G equals... So g equals 4 pi squared. You'll need to find the actual value for that. Only square pi. Don't square the 4 also. Over whatever your number is here. Your slope. So that's how you'll get your value for g. Now, hopefully that number is close to 9.8. There's a decent chance it won't be, and that's okay. So now, number 11. Let's see how you did. Use the percent error equation below to determine how close your measured value for g, what you got in number 10, is to the expected value for g, which is 9.8. Show your work below. The expected is what you think you should get, 9.8. The measured is what you actually got, your answer for 10, whatever it is. Okay? That'll give you a percent error, and you just write that number down here. Yes, it can be negative, and that's fine. Don't worry about if it's negative. All right, lastly, conclusion. Use your percent error value from number 11 to discuss the accuracy of your lab results. So percent error less than 20% is okay. Percent error less than 10% is great. Anything greater than 20% is poor. Why do you think you got the value seen above? Use evidence from the lab. So what you're going to do for 12 is you're going to explain to me how good are your numbers. Okay? If you got less than 10%, your numbers are great. You can say that the lab behaved the way you thought it did. You can explain that gravity behaved the right way. You can talk about the length doing what it should do. You can talk about being consistent in your measurements, all that kind of stuff. If you got between 10 and 20%, you can talk about that for the most part it worked out like you thought, but maybe you were not as consistent or the amplitudes, or maybe your amplitudes were too big, or maybe you didn't change your lengths by very much. I noticed some of the groups, the lengths change by very small amounts. That's going to open you up to more error because those numbers are so close together. Every number has an error of about 0.1 to 0.2 seconds. So if all of your numbers are really close, the errors are going to overlap, and it's easy to get numbers that don't work out as well. So maybe you didn't change your length by enough. They're too close together. Maybe you made your amplitude too large. Maybe you weren't consistent in that. Maybe you didn't do enough oscillations. There's lots of explanations. If you have less than 10% error, you don't need to do too much explaining. Overall, you are pretty good. If you are less than 20% but more than 10, you need to do a little bit of an explaining, but overall you were fine. If you're over 20%, you should explain quite a few things that went wrong. The numbers were too close together for the lengths. We made the amplitudes too large. We used too small of lengths. We didn't time the way we timed didn't work out the way we thought it would. There's a lot of explanations for what you could have. But basically, you want to explain why do you think you got the number you got. You should get a number close to 9.8. You're explaining why is it not exact. Any questions for me? All right, let's give you a little bit more time here.